So, we will continue our discussion on this rotation of a molecule. Rotation of a molecule. So, rotation of molecule, what it gives? It gives basically the microwave radiation. Microwave radiation. So, we want to see how it is giving, this rotation of a molecule is giving microwave radiation, microwave electromagnetic radiation. Okay. So this so when we would like to study the rotation of a molecule. So basically, so rotation of a molecule, see you have a say simple molecule, diatomic molecule, two atoms separated by distance. So two atoms separated by distance. So this distance is basically it's called say bond length. Okay, bonding between these two atoms. So it's called bond length. So this to study the rotation of a molecule. So rotation about an axis, right? Rotation of anything that is basically about an axis. Okay. So we have to define axis to study the rotation of the molecule. So generally three mutually perpendicular directions through the center of mass, So here if these two molecules are identical, their mass are identical. So center of gravity or center of mass, it will be in middle. If one is size is higher like HCl, okay, and another is smaller, so its center of gravity it will be it will not be in middle, it will be close to the higher mass. So we have to define, basically we define that three mutually perpendicular directions. So that is the x direction, say along this is the x direction, along this it can be y direction, okay, and perpendicular to this board, so that is z direction. Okay. So rotation of this molecule, it can be about the axis x axis, it can be about the y axis, it can be about the z axis, or it can be about any arbitrary axis. So if it is about any arbitrary axis, so that can be that one can get in terms of these three mutually perpendicular axis. Okay. So for linear motion, mass is important. So in case of rotation, equivalent is the moment of inertia, right? Mass is equivalent to moment of inertia. Okay. So whatever the role mass plays in case of linear motion, so that same role is plays by this moment of inertia. So moment of inertia is defined as mr square, right? So from the axis, okay, from the axis of rotation, what is the distance of this mass? If it is r, okay, so this moment of inertia is I equal to m r square, right? So so this moment of inertia, so it's if it is this axis is x axis, so then we can write this is Ix. If it is about the moment of inertia, Ix means this axis of rotation is x direction. So similarly Iy, if it is with respect to y direction, and then Iz. So Ix, Iy, Iz is basically three moment of inertia with respect to three mutually perpendicular directions, x, y and z direction. So which axis it is molecule is rotating. So, that is important because of moment of inertia, because from that axis one has to take distance of the mass, right. So, direction is important. So, that is expressed. So, that effect of direction or axis chosen, so that comes through this moment of inertia. So, that is why if I write moment of inertia is Ix or Iy or Iz. So, indirectly it is telling what is the axis of rotation. Okay. So, depending on this axis of rotation or moment of inertia, we can define this basically depending on the molecule and their axis of rotation. So, we can differentiate molecules and their rotation. So, let us see some example that linear. So, different kind of molecules are there. Okay. So, if we differentiate them in terms of their arrangement or in terms of their axis of rotation. Okay. So, this one type will be called linear molecule. Okay. Linear molecules means atoms are arranged linearly in that molecule. So, like HCl is linear molecule because H, hydrogen and chlorine, they are arranged linearly. So, HCl is the example of linear molecule HCl. Okay. H2 also they are or Cl2 also they are linear molecule. And so, this here whatever example I have given. So, this called diatomic molecule. So, diatomic molecule is all the time is linear molecule. Diatomic molecule is always linear molecule, but it is not necessary that diatomic molecule is only linear molecule, but polyatomic molecule also can be linear molecule. So, diatomic molecule. So, polyatomic example of polyatomic molecule. So, these are the nomenclature for molecular spectroscopy. So, polyatomic molecule, it can be also this linear molecule, say carbon dioxide CO2. So, it's more than 2 atoms. So, their arrangement is like this, Okay. So, this is linear molecule. Okay. So, similarly, I think carbon oxysulfide So, these also linear molecule. Okay. Now, so linear molecule, it can be diatomic molecule, all the time it is linear molecule, there is no choice. Okay. But polyatomic molecule also can be linear molecule, but I think most of the polyatomic molecule are not linear molecules, but there are many examples of linear molecule. So, here I have given 2 examples. So, one is carbon dioxide, another is carbon I think this is written like this, OCS, carbon oxy sulfide. Okay. So that is carbon oxy sulfide, OXY oxy sulfide, OXY or OXI, it can be OXI probably, yes. So carbon oxysulfide, okay. So it's the example of linear molecule, and it is polyatomic molecule. Now here I have given this for diatomic molecule. So HCl and generally, so H2 Cl2, these are the diatomic molecule and they are linear molecule, but all these linear molecule, it will have rotation. Okay. So it will have rotation. There is no there is nothing wrong to have the rotation of this molecule, but as I mentioned earlier, H2 and this HCl, they are not microwave active, they are microwave inactive because they don't have permanent dipole moment. That means neither it will emit microwave nor they will absorb microwave. Okay. So, but they will have this rotation, and they will not show any spectra molecular, they will not show any molecular spectra in the microwave range. Okay. So, due to rotation of this microwave non-active molecule, will not get any microwave spectra. Okay. But whereas this HCl will give microwave spectra. Okay. So this is microwave active molecules, this is microwave inactive molecule. Similarly, for polyatomic molecule, this one, carbon dioxide, it is not having the permanent dipole moment. Okay. It will not have the permanent dipole moment, whereas this carbon oxysulfide, it will have permanent dipole moment. So in this case, this also will not, it is microwave inactive, whereas this other one is microwave active. Okay. So these are the example of linear molecules. So that in case of linear molecule, so axis of rotation Ix, Iy, Z, you can just tell that in case of linear molecule, I y equal to I z. Okay. So equal to, I can write I because both are, and Ix equal to 0. Okay. So Ix, x direction is taken in this direction. Okay. So Ix, obviously it will be 0 because from this axis the distance of mass is 0, right. So I equal to mr square, distance r is 0 from this axis. So obviously your moment of inertia Ix is 0. So for linear molecule, so only there is only one moment of inertia, because of symmetry, either it is rotating with respect to y axis or with respect to z axis, is basically same. Okay. So it is linear molecule have only one moment of inertia, whereas so when the molecule will have only one moment of inertia, okay, then obviously it will be called the linear molecule. So for other example, we tell that is basically second case. I can tell this second case I can tell that this the other kind. So, this spherically top molecule, spherically top. So, it is in case of this linear molecule, it is in case of polyatomic. So, all the diatomic molecule under this group linear molecule, some polyatomic molecule also in this group. Rest of the other polyatomic molecules, it can be either it can be in this group spherically top molecules, or third type it can be symmetrical top molecules, symmetrical top molecule, symmetrical top molecule, symmetrical top molecule, symmetrical top molecule. Okay. And other case it can be asymmetric top molecule. Other kind can be is 4 kind of 4. Below I have space. Okay. So, I can tell this asymmetric top molecule. Okay. So, polyatomic molecule, it can be linear molecule, it can be spherically top molecule, or symmetrical top molecule, or asymmetric top molecule. Okay. So, in case of spherical top molecule, example I can give you spherical top. So, basically this kind of tetrahedrally bonded. Okay. So, spherically it will be spherically top when it is the carbon, and here hydrogen, here hydrogen, here hydrogen is basically methane, you know, it's methane. So, methane there it's called spherically top molecules. So, this basically in this case this arrangement of this charge is basically it has spherical symmetry. Okay. It has spherical symmetry, and in this case you can define this x, y, z direction in such a way. So, and you can show that, you can see that y, so this Iy equal to Iz, fine, but Ix is not equal to 0. Ix is not equal to 0. Okay. So, in case of spherically symmetric, so Iy equal to Iz, okay, you can define this axis in such a way, x, y, z axis. Okay. So, you will have y equal to Iz, but Ix is not equal to 0. So, that is the difference between this linear molecule and this spherically top molecule. Okay. And symmetric top molecule, what is symmetric top molecule? Symmetric top molecule is not spherical top. So, if you replace this one F by F, okay, if you methyl fluoride, basically earlier it was a methane. So, now it is methyl fluoride. Okay. So, these 3 are hydrogen, this one is fluorine. Okay. So, then it will be called symmetric top molecule. It will be called symmetric top molecule, and in this case your symmetric top. So, I think this is the mistake I have done. So, in this case I have done mistake. So, for spherical top molecule you can define this one Ix equal to Iy equal to Iz, Ix equal to Iy equal to Iz, when the spherically symmetric. Okay. So, this is the case, but in case of this symmetric top, when it is methyl fluoride, so in that case, so Iy equal to Iz, but Ix is not equal to Ix, okay, and Ix is not equal to 0. Okay. So, yes, so spherically tough, here basically Ix equal to, I think I will use different color. So, Ix equal to Iy equal to Iz, okay, and symmetric top molecule, this is the example. So, here spherical top molecule example is methane, CH4 methane, and symmetrical top molecule, this is the methane fluoride, CH3F methyl fluoride. Okay. So, this is symmetrical top molecule, and in this case basically your Iy equal to Iz, but not equal to Ix, and Ix is not equal to 0. Okay. Ix is not equal to 0. So, this is the here whatever I have written. So, that is basically for symmetrical top molecule, and then asymmetric top molecule. So, asymmetric top molecule example is for asymmetric top molecule example, say example I can tell this water O, and then you have hydrogen, okay. So, this water molecule is basically H2O, it is H2O. Water molecule have asymmetric, is called asymmetric top molecule, because in this case basically Ix is not equal to Iy, is not equal to Iz, okay. So, in terms of moment of inertia, the molecules are divided into different types. So, those molecules are called linear molecule when it will have only one moment of inertia, okay, only one moment of inertia, principal moment of inertia. It's called principal axis, with respect to principal axis, principal moment of inertia, okay. So, that is the linear molecule. It can be diatomic molecule, it can be polyatomic molecule. So, that example I have given. So, second is spherically top molecule. So, when all three moment of inertia exist, but they are equal, okay, Ix equal to Iy equal to Iz, okay. So, it will have also basically one moment of inertia equal to I, okay, but in this case Ix is not equal to 0. So, that way spherically symmetric molecule is different from the linear molecule, okay. So, this is the in case of spherical top molecule, all those molecule will be called spherically top molecule when their principal moment of inertia are equal. Yes. Then symmetrical top molecule, it will be those molecules which will have this moment of inertia. I think here I should write, yeah, say Iz equal to Iy is not equal to Ix, Okay. So, and Ix is not equal to 0. So, so it is different from this spherical top molecule or linear molecule. Okay. So, in this case Iy equal to Iz, but Ix is 0. So, linear molecule, when Iy equal to Iz is not equal to Ix, okay, and Ix is not equal to 0. So, then this is spherical and this is symmetrical top molecule. Okay. And when Ix, Iy, Iz, they are not equal with each other and they are not 0 also. Okay. So, Ix is not equal to Iy, is not equal to Iz. So, if this is the case, so those molecules are called asymmetric molecules. Okay. So, depending on the axis of rotation and their corresponding principal moment of inertia, so this in molecular spectroscopy, molecules are differentiated by this way. Okay. So, I will stop here, then I will continue in next class. Thank you.